back to the Curious Kid podcast. I have a really good feeling about this episode. I feel like it's going to be out of this world.
Mailbag!
Mailbag! Hello, Jacob and Olivia. It's Caleb and Micah. We just listened to Curious About Garbage and Curious About Batteries while eating breakfast. We are catching up on episodes and look forward to learning more. You make the subjects so fun. Micah is curious about stars. We thought it would be a good follow-up to Curious About the Moon. And Caleb is curious about soccer. We love the podcast and think you two are doing a great job.
Thank you so much for the email, Caleb and Micah. We are getting curious about stars this week for you.
Stars are super duper interesting, and there is so much to know. I learned a ton about stars doing research for this episode.
Let's shoot for the stars, Daddy. I'm ready to learn.
There's a lot to learn, so let's get to it. What's the question of the week?
The question of the week is, how much larger than the sun is the largest known star?
The star we are talking about is called VY Canis Majoris, and it is the largest known star. Can you guess how much bigger it is than the sun? Why are we comparing stars to the sun anyway?
Because the sun is a star, the closest star to Earth.
That's right. The sun is a star, and it is the center of our solar system. If it's the closest star to Earth, it's gotta be pretty close. How far from the Earth is the sun?
The sun is about 93 million miles away from Earth.
That is insane. It is so far away. And all of the other stars are even further away. Yet we are able to see them on a clear night. And that's amazing.
Stars are giant spheres that are made of very hot gases.
Those super hot gases are hydrogen and helium. Stars burn hydrogen to form helium. That process is called nuclear fusion.
Nuclear fusion is what makes stars so bright and so hot.
Let's learn a bit about the life cycle of a star. Stars are born from molecular clouds, also called nebula, that contain 97% hydrogen and 3% helium. The nebula collapses, and as it breaks apart, it forms a dense sphere called a protostar.
These protostars have dust and gas, but don't create light.
The protostars grow larger and larger, and the gravity in the protostars also increases. Once the center or core gets hot enough, nuclear fusion will begin.
Now the star is born. It spends almost all of its life as a main sequence star.
That's like the adult stage of the star. Stars will stay in the adult phase for a very long time because stars live for millions or billions of years. Stars will leave the main sequence star phase when it runs out of hydrogen to burn.
The star has no more energy to burn and is just the core of the original star.
The star is still alive and it's still very hot, but now it starts to cool off. This process takes millions of years. Then, one of two things will happen. One is that the star will get cold and stop burning off energy completely.
Or the star could explode in something called supernova.
Supernovas are incredible. It's a huge explosion that is brighter than anything else in the galaxy. In our galaxy, the Milky Way, supernovas happen about twice every century. In the entire universe, which is much, much bigger than the Milky Way, supernovas occur as often as every 2 seconds. The star residue that remains after a supernova will eventually be used to make new stars. That is just fascinating.
The bigger the star, the quicker it will die. Small stars live a longer time.
That's because big stars burn hydrogen quicker, and stars begin to die once all of the hydrogen is gone. But again, even the stars that die quickly will still last millions of years. Let's learn about the different types of stars you can see in the night sky.
The smallest stars are red and don't glow that much.
Medium stars, like the sun, are yellow.
The biggest stars are blue and they are very bright.
The smaller stars are called dwarf stars. Red and yellow stars are usually dwarf stars. Brown dwarfs are small stars that never get big enough for nuclear fusion to happen.
Most of the stars in the universe are red dwarfs.
The bigger stars are called giants. That makes sense. They could be adult stars like blue giant stars or expanding stars like red giants. The biggest stars are classified as supergiant stars. Some supergiant stars are as big as the entire solar system.
The hottest stars are blue and the coolest ones are brown.
Usually we associate blue with being cold and red with being hot. When it comes to stars, all stars are hot, but the hottest ones are actually blue. It's similar to what we learned when we got curious about fire in episode 42. Blue flames are hotter than red flames. Likewise, blue stars are hotter than red stars. From coolest to hottest, stars go from brown to red to orange to yellow to white and then to crazy hot blue stars that can get as hot as 28,000 degrees Celsius. That's over 50,000 degrees Fahrenheit.
The sun is classified as a yellow dwarf star.
Can you imagine that? First of all, because it's a dwarf star, it is relatively small compared to other stars. Also, it's yellow, which means it's not nearly as hot as white or blue stars, and yet it is able to keep us nice and warm from 93 million miles away. Mind blown.
There are between 200 billion and 400 billion stars in the Milky Way.
That's crazy. But check this out. The total number of stars in the universe, which includes all of the galaxies, is as many as 300 sextillion. How much is 300 sextillion? It's the number 300 followed by 21 zeros.
Looking up at the stars is like looking back in time.
It takes years for the light from stars to reach Earth. That means that looking up at the stars in the sky is literally like looking back in time. The closest star, aside from the sun, is called Proxima Centauri, and it is 4.3 light years away, meaning that it takes over 4 years for the light to reach the Earth. By the way, just because Proxima Centauri is the closest star to us, that is not the sun, doesn't mean it's close. If you took the fastest spacecraft ever launched on a trip to Proxima Centauri, it would take you almost 70,000 years to get there.
Stars don't really twinkle. You were lying, Daddy.
Okay, that's a bit harsh. I guess you must be talking about the nursery rhyme, Twinkle Twinkle Little Star. You're right. Stars don't really twinkle. It's air in our atmosphere that moves around between us and the stars that makes it look like the stars twinkle, but they don't.
Yeah, stars don't twinkle, and they aren't little either.
You're absolutely right. In fact, just a few years ago, 2 astronomers rewrote the words to Twinkle Twinkle Little Star to make the nursery rhyme scientifically accurate. And they were kind enough to give us permission to read their brilliant version of the nursery rhyme on the podcast. Before we get to that, let's answer the question of the week. The name of the largest star is known as VY Canis Majoris. How much bigger is it than the sun?
It is 1,800 times bigger than the sun.
That is astounding. There were so many crazy, fascinating things we learned this week. I'm about to read you the scientifically accurate version of Twinkle Twinkle Little Star that will help us recap what we learned about stars in this episode. The lyrics were written by astronomers Julia Kregenow and Jason Wright. Copyright 2011, 2012, 2015. We hope you enjoy it. Twinkle, twinkle, little star, I know exactly what you are. Opaque ball of hot, dense gas, million times our planet's mass. Looking small because you're far, I know exactly what you are. Atmospheric turbulence causes rays of light to bend. Blurry light gives views subpar, causing twinkling little star. We see you as if in the past. Lights not infinitely fast. Look back time delays our view. I know exactly what you do. Fusing atoms in your core. Hydrogen, helium, carbon, and more. With such power you shine far. Twinkle, twinkle, little star. Classed by their spectroscopy. Types named OBAFG. Bright when close and faint when far. I know exactly what you are. Smallest ones burn cool and slow. Still too hot to visit though. Red stars dominate by far. Twinkle, twinkle, little star. Largest ones are hot and blue. Supernova when they're through. Then black hole or neutron star. I know exactly what you are. Gravity holds on too tight. Nothing gets out mass or light. Black holes are the most bizarre. Remnants of a twinkling star. Neutron stars spin really fast. When their beams of light sweep past. Then we call you a pulsar. I know exactly what you are. Our sun's average as stars go. Formed 5 billion years ago. Halfway through its life so far. Twinkle, mid-sized yellow star. Sunspots look dark, but they're bright. Slightly cooler, so less light. Temporary surface scar. I know exactly what you are. Swelling up before it's dead. Cooling off and growing red. Then its end is not so far. Twinkle, big red giant star. Outer layers float away. Planetary nebulae. Wispy gas is gossamer. I know exactly what you were. White dwarf is the core you get. Matter is degenerate. When small stars say au revoir, twinkle, twinkle, little star. Interstellar medium, recycled ad nauseum. Gas and dust are spread afar. I know exactly what you are. Forming from collapsing clouds, cold and dusty gas and shrouds. Spinning, heating protostar, twinkle, twinkle, little star. Often forming multiply. Clusters bound by gravity. Open type of globular. I know exactly how you purr. 2 stars make a binary, or a triple if there's 3. Some are solo just like ours. Twinkle, twinkle, little stars. 200 billion stars all stay, bound up in the Milky Way. Dusty spiral with a bar. I know exactly what you are. Stars have planets orbiting, rocky or gassy moons or rings. Earth's unique with life so far. Twinkle, twinkle, little star.
That was amazing. It was so much fun learning about stars. If you enjoyed this episode, check out episode 13 on the moon.
That was so much fun. Well, that's a wrap for this week's episode.
Thanks so much for listening to this week's podcast, number 106, on stars.
Great job, Olivia, and great job, Micah and Caleb, for that fantastic listener suggestion. Next week, we are going to take a 1-week break from listener suggestions to get curious about Election Day, which is coming up in just a few weeks. Following that, we are going to take a listener suggestion to get curious about rats, just in time for Halloween. As always, thank you so much for listening and getting curious with us.